Good evening, children.
Good evening.
Yeah, good evening. How many of you completed the assignment I shared last week? Case study based questions and assertion reasoning.
Ma'am, I have completed it, ma'am.
Yeah, me. Yeah, those who have completed the assignment, raise your hand. Use the emoji, raise your hand. Akshana, what about you?
Ma'am, I completed for 5 chapters, but remaining I didn't.
Okay, you've not completed in full. Okay. All right. What about Saujanya, Shivam, Ariston? Okay, so today we are taking the introduction to the chapter mensuration, a very important topic. So here we shall understand how to find the area and perimeter of plane figures first. And then we'll move on to solids. We'll learn how to find area, the total surface area of some specific solids. Okay, so first, square. So we all know the formula to find the area of a square is a square. Area of a square is given by the formula a square or side square. Side square or a square, square units. Perimeter of a square. Perimeter of a square is given by the formula 4a, 4 into side. 4 into side or 4a units. The length of the diagonal of a square. Length of the diagonal. Let's find that. Square, diagonal, corners are right angles. All the sides equal to a units. So if you call this square ABCD, in right triangle ADC, in right triangle ADC, every corner, every other corner is a right angle. In a square, every other corner is a right angle. Okay, so here we take up this right triangle ADC, ADC, where an angle D is equal to 90 degrees. So AC is the hypotenuse. AC is the hypotenuse because it's the side opposite to the right angle. So the diagonal AC of the square is the hypotenuse of the right triangle ADC. So in right triangle ADC, by Pythagoras theorem, we have AC square is equal to AD square plus CD square. So AD is A, so A square plus A square, 2A square. So AC square is equal to 2A square. So AC is equal to square root of 2A square. So AC is equal to root 2 square root of A square. Square root of A square meaning square root of A into A. So from 2 A's, 1A comes out. From 2 A's, 1A comes out. So root 2 A units. 2 remains under the square root. 2 remains under the square root. There are 2 A's. So 1A out of the square root. So the formula to find the length of the diagonal of a square is root 2A units. Root 2A units. So length of the diagonal. Length of the diagonal is given by the formula root 2 into side or root 2 A units. Yeah, write on all this, children, quickly. Done writing, children?
Just two.
All right. Ariston, are you there? Are you there, Ariston? No. All right. Next one. Done. Student. Next, rectangle. So you know a square is a plane figure. It's two-dimensional. A square is a plane figure. It's two-dimensional, meaning it can be represented on a flat surface. You can represent, you can show how a square exactly looks like on a flat or a plane surface. So that's why we say a square is two-dimensional. A rectangle is also two-dimensional. It has only length and breadth, only two dimensions, length and breadth. So it's a plane figure. It can be represented on a flat surface. Both square and rectangles, they are plane figures. They are two-dimensional, meaning they have length and breadth. They can be represented on a flat or a plane surface. Rectangle, area of a rectangle is equal to L into B, length into breadth, square units. perimeter of a rectangle is equal to 2 into L plus B units. You don't need an explanation for all this. You know this very well. Perimeter is equal to 2 into L plus B units. Length of the diagonal of a rectangle. See, in both a square and rectangle, the diagonals are equal. In both a square and a rectangle, the diagonals are equal. See, here we found the length of the diagonal AC. The same will be the length of the diagonal BD, because in a square, diagonals are equal. Diagonals are equal. So if AC is root 2A units, BD is also root 2A units. Likewise, in a rectangle, the diagonals are equal in length. A rectangle has two diagonals. Like a square, a rectangle also has two diagonals, and both the diagonals are equal in length. Length of the diagonal. Rectangle. Let's take one of its diagonals. Let's name the rectangle PQRS. Let's name the rectangle PQRS. You can take any triangle. Let me take this triangle. This corner is a right angle. So let me take the right triangle PSR. In right triangle PSR, by Pythagoras theorem, the hypotenuse is PR because that's the side opposite of the right angle. So PR is the hypotenuse. So the hypotenuse square, the square on the hypotenuse is equal to the sum of the squares of the other two sides. The other two sides are PS and SR. The square on the hypotenuse is equal to the sum of the squares of the other two sides. The triangle is PSR. The three sides of the triangle PSR are PS, SR, PR. These are the three sides, PS, SR, and PR. Now, of these three sides, PR is the hypotenuse because that's opposite of the right angle. So the remaining two sides are PS and SR. Square all of them. Square all of them. Hypotenuse square is equal to the sum of the squares of the other two sides. This is the hypotenuse. Put an equal to sign. Write the remaining two sides here, PS and SR. Square all the three sides. Add. So this is what is Pythagoras theorem. In a right triangle, the square on the hypotenuse is equal to the sum of the squares of the other two sides. So PR square is equal to PS square plus SR square. This is L, this is B, this is L, this is B. So PR square is equal to PS is L square plus SR, B square. So PR is equal to square root of L square plus B square, which is not L plus B, because square root of A square plus B square is not equal to A plus B. But square root of A square into B square is equal to AB. If you have square root of 100 plus say 49, it's not equal to, it is not equal to square root of 100 is 10, square root of 49 is 7, so the answer is 17. This is wrong because because it's wrong because you need to get the same answer both the ways. What if we add? When we add, we get 100 plus 49, 149, square root of 149. And clearly, 149 lies between 144 and 169, meaning 12 square and 13 square. 12 square is 144, 13 square is 169. Now this 149 lies between 144 and 169. So its square root will be 12 point something. Because the square root of 144 is 12. The square root of 169 is 13. Now 149 lies between 144 and 169. So its square root will be somewhat like 12 point whatever or 12.0. We don't know. So something like that. But it's 12 point something. It's between 12 and 13. But you're getting 17 here. See, it is true if you get the same answer either ways. Both the ways you must get the same answer. Then it is true. But we are not getting. We are not getting the same answer. Same situation. When you add this, you get this one, and its square root is some 12 point. But the same thing, if you find the square root separately, you get 17. You're getting two different answers. That means it's not equal. Root of a plus b, root of a square is a square, okay? So root of a square plus b square is not equal to a plus b because you're getting different answers. Which is correct? You should add. You must add and then find the square root. This is the correct method. 100 plus 49, you should add 149 and then find the square root. This is wrong. All right. So remember, square root of L square plus B square is not equal to L plus B because it's addition. For addition and subtraction, it's not true. If it's multiplication, root of L square into B square, yes, it is equal to L into B. Or if it's division, root of L square by B square, yes, it is L by B. Square root of L square is L, square root of B square is B. It's fine for multiplication and division, but not for addition subtraction. So then what is it? It's root of L square plus B square itself. So PR is equal to square root of L square plus B square units. So the length of the diagonal of a rectangle is given by the expression or is given by the formula root of L square plus B square units. Please write down, children. Finished writing? Raise your hand, children. If you've completed writing, raise your hand. on it. Yeah, so the next plane figure is a circle. Now the area of a circle is given by the formula pi r square. Pi r square, square units. Pi is an irrational number. Pi is an irrational number. It has a non-terminating, non-repeating decimal expansion. Non-repeating decimal expansion. Area is equal to pi r square, square units. Pi is an irrational number. It has a non-terminating, non-repeating decimal expansion. But for the sake of calculating area, we take pi as 22/7. The value of pi is not at all 22/7. It's a very, very rough, estimate. Just for the sake of computation, you need to find the area of the square, right? Using the formula pi r square. Then you need to give some definite value for pi. You cannot write the non-terminating, non-repeating decimal. It goes on and on, to more than millions of decimal places. So we take an approximate value for calculation. So we either take pi is equal to 3.14. This only if it is given or if it's provided in the question. Default value of pi that you should take is 22/7. Nothing is mentioned. You should take 22/7. You must take pi is equal to 3.14 only if given in the question. Only if given in the question. It'll be mentioned in the question, that you have to take the value of pi as 3.14. If that specification is given, then take 3.14. If nothing is mentioned, you have to go with 22/7. So 22/7 into radius into radius. R is the radius of the circle. 22/7 into radius is the formula to find the area of a circle. Perimeter. Perimeter we all know is the length of the boundary. In any closed figure, perimeter is the length of the boundary. So the length of the boundary of the circle, this length is the circumference or the perimeter. Perimeter or the circumference of the circle. Circumference. Perimeter of circumference. Okay, the length of the boundary is given by the formula 2 into pi into r. 2 pi r. 2 pi r units. What is 2r? 2r is nothing but d. Twice radius is diameter. Or it is also pi d. It's also pi d. Because what is 2 into r? D. So pi d. Or it is equal to pi d. Units. The length of the boundary of the circle is given by the formula 2 into pi into r. 2 pi r units. Since 2 into r is diameter, you can also use the formula pi into d, pi into diameter. So 2 into pi into r multiplication, you can change the order also. So it is nothing but pi into 2 into r. Pi into 2 into r. So pi into 2 into r is d. So pi d. Pi into diameter. So the length of the boundary of a circle, which is the perimeter or the circumference of the circle, is given by the formula 2 pi r or pi d units. Yeah, right on, children. Next we'll see semicircle, then quadrant. Right on. Two into pi into r or pi d.
No, that's it is the perimeter.
Or circumference slash perimeter slash circumference.
Slash.
Circumference. CIRCUM circumference. FERENC. Circumference. Circumference. CICUM circumference. Right? Semicircle. Correct? This is semicircle, right? This one is a semicircular region. This one is a semicircular region. Semicircular region. The entire thing, the whole thing is a semicircular region. Semicircle because half of a circle. Circle. Each half is called a semicircular region, or simply semicircle. Each half of a circle is called a semicircular. Actually, it is a semicircular region, but we say semicircle. This region is called the semicircular region. Semicircular region. So what do we see in a semicircular region? We see the diameter and half of the boundary of the circle. We see the diameter. In this semicircular region, we see two things. One is the diameter of the semicircle or the circle, the diameter. Then this one is half the circumference of the circle, half the length of the circle. Okay. So area of a semicircle. Area of a semicircle is given by the formula half into pi r square. Area is equal to pi r square is the area of the circle. Semicircle is half of it. So half into pi r square, or it is pi r square by 2 square units. A semicircle is half of a circle. So its area is equal to half into pi r square. Because pi r square is the area of a circle. Half of it will be half into pi r square, or pi r square by 2 square units. Perimeter of the semicircular region, or I'll just say perimeter, given the heading semicircle. Perimeter. So here we have to be careful. Perimeter, you cannot simply say it's half of 2 pi r. Okay. See, because here the perimeter is 2 pi r. So going with this formula, we feel it is half of 2 pi r. But it's not like that, I'll tell you. Now, look at this figure. Look at this figure. What makes the perimeter, or what is the perimeter? It's the length of the boundary. Now, what do you see in the boundary? We see the diameter here. We see the diameter. And we see this arc. This one is called an arc, actually. It's an arc. We see this arc. The length of this arc is half into 2 pi r. Because the full thing is 2 pi r. The length of this full, this full thing, this full circle is 2 pi r. So half of it, this is half of it. So the length of this portion, or the length of this arc, will be half into 2 pi r. This one is d, or it is r plus r. Radius plus radius. The length of this full thing. This is center. Radius, radius. From here to here is a radius. And again, from this portion to this portion is a radius. The perimeter of the semicircular region is nothing but the length of its boundary, which is pi r plus r plus r. So pi r plus 2r units, or 2r plus pi r. 2r plus pi r. If you take out r common, you get pi plus 2 units. See, if you're trying to find the length of only this arc, then it is half into 2 pi r. So it is pi r. The length of this arc is pi r. But the semicircle comes with this one. We are talking about the perimeter of a closed figure, the semicircular region. So this is the semicircular region, which has this arc whose length is pi r, and this line segment whose length is r plus r. So the perimeter of this shape, or the perimeter of the semicircular region, is equal to pi r plus r, pi r plus 2r, r common, pi plus 2 units. I repeat, see here, this full thing is 2 pi r. Circle, this full length is 2 pi r. So half of it, half its length will be half into 2 pi r. So the length of this one is pi r. This is pi r. The length of this arc is pi r. But here what we have to find? We have to find the perimeter of the semicircular region, which comes like this. So this one is pi r, and this one is r plus r. So pi r plus 2r, r common, pi plus 2 units. If this is clear, raise your hand, children. Lower your hands and raise your hand again. If this is clear, All right, children. Yeah, let's proceed. Yeah. So area of a semicircle, half into pi r square. Or pi r square by 2 square units. Perimeter will be pi r plus 2r. Pi r plus 2r units. Yeah, I think we have to write down this. Yeah, write down, children. Next, we'll see quadrant. I'll let you know. Next one. Quadrant. Semicircle is half of a circle. Quadrant is 1/4 of a circle. Quadrant. So see here, circle. You divide this into 4 equal halves. Each 4 equal parts. 4 equal parts. Each part is called a quadrant. Divide the circle into 4 equal parts. Each part is called a quadrant. So how does a quadrant look? Like this. Like this. Now, this is the radius. You can see from here to here, this is the radius. From here to here, this is the radius. And we have an arc here. Well, area is 1/4 into pi r square. Area is equal to 1/4 into pi r square or pi r square by 4. Pi r square by 4 square units. Perimeter is what is important. Perimeter is equal to. So what do you see in the boundary? You see this line segment which represents the radius. You see this line segment which also represents radius. And you see an arc here. You need to find the length of this arc. And we know that the length of this arc is equal to 1/4 into 2 pi r. Because the length of the complete circle is 2 pi r. This full length is 2 pi r. This full length is 2 pi r. So 1/4 of it, the length from here to here, 1/4 of it will be 1/4 into 2 pi r. You're dividing the length of the circle into 4 equal parts. This one, the length of this full thing, the length of the complete thing, this complete length is 2 pi r. What you see here is 1/4 of the full thing. So 1/4 into 2 pi r. So 2 ones are 2 twos are. So nothing but pi r by 2. Pi r by 2. 2. So perimeter is equal to, perimeter is the length of the boundary. So what all you see in the boundary, or what are the lengths of the, the three different things you see in the boundary? There are two line segments and one arc. The length of one line segment is R. The other line segment is also R. Then there's one arc. What's the length of this arc? Pi r by 2 plus pi r by 2. So it is 2r plus pi r by 2 units. You can even take one r common, but it's okay. You can just leave it like this also. If you take r common, then you'll have r common 2 plus pi by 2 units. You don't have to remember all this, meaning you don't have to remember the formula like this and like this. It's enough if you can write it like this. It's enough if you can remember this. So a quadrant, see the line segment attached to the semicircle is the diameter. The line segment which is attached to the semicircle, the line segment attached to the semicircle is the diameter. This one is the diameter, r plus r. The line segment which is attached to the quadrant, this is the quadrant. These line segments are this one radius, this one also radius. There are two line segments here. Both of them represent the radius of the circle. This is the center of the circle. So from here to here radius, center of the circle from here to here radius. And the length of this arc is pi r by 2. I showed you here. 2 pi r is the full length. 1 by 4 into 2 pi r. So pi r by 2. Yeah, right on, children. Please write down. Done, children?
Done, ma'am.
All right. Harrison?
Yes, ma'am.
Yeah. Name all the plane figures we have seen so far.
Yes, ma'am. We have seen quadrant, circle, semicircle, rectangle, and a square, ma'am.
Okay. I didn't see you in the meeting for some time.
Yeah, ma'am. I just went to the washroom.
Okay. All right. Now I have a question for you all. Help me find the perimeter of this shape. One second. Okay, this one is an equilateral triangle, children. It's an equilateral triangle. And on each side of the triangle, a semicircle is described. On each side of the equilateral triangle, a semicircle is described. Let me call this ABC. ABC is an equilateral triangle. Say the side of the triangle is 14 centimeters. 14 centimeters. On each side of this equilateral triangle ABC, semicircles have been described. Now just tell me the expression to find the perimeter of this figure. I just want the expression. You meaning just say something like 2 pi r plus d plus this plus that. I don't want any numerical answer, or I don't want you to tell me anything numerically, just using the variables in the formula.
And can I say
Yes.
pi r plus r plus r?
Ma'am, can I say
Yeah, 1 minute. Let me just finish with Shreya. Shreya, pi r
Plus r plus r.
pi r plus r plus r. Okay. Okay. Yeah, who is that? After Shreya?
I'm Lakshana?
Lakshana, yes.
I'm 3 into pi r.
3 into pi r, is it?
Hmm.
Okay. Yes. Sorry. Let me tell you. 14. 14. Yes. Please try. Others? Gayatri, Saujanya, Aishwarya, Ariston, Shivam, Yarni. Yarni, tell me. Okay. So, Shreya, well tried. Lakshanya, you're right. So, when we say perimeter, it's you just have to go along the boundary of the figure. You should not get inside the figure. Just go along the boundary. So, supposing you start walking from A, you have to go along the boundary. The outermost part of the figure, boundary, the outermost part of the figure. So when you're walking along the boundary, you're not walking along AC. No, AC, AB, BC, and AC, the line segments are inside the figure. But when it is perimeter, you are going to walk on the boundary, the outermost portions of the figure. So If you have to walk along the boundary, this is how you will go. You start from A, then you walk along this path like this. You walk like this and you reach C. So what is the distance covered by you? Pi r. Because this is a semicircle. The length of the semicircle is pi r. It's not pi r plus d, children. If this line segment is included, then it is pi r plus d. Or pi r plus 2r. This alone, the length of this alone is pi r. This is radius, this is radius. The perimeter of this full thing is pi r plus 2r. But the length of only this arc is pi r because it's 2 pi r by 2. Half of 2 pi r. Pi r. I told you they're semicircles. So the length of this arc is pi r. So from A, you walk along this boundary, you reach the point C, the distance covered is pi r. Now from C, you walk along this path and you reach the point B. Again, you have covered a distance equal to pi r. And from B, you walk along this path to go back to the starting point A. So when we say perimeter, you need to start at a point, walk along the boundary and come back to the starting point. That means you have gone one round along the boundary of the closed figure. You started at A, you walked along this path, the distance covered is pi r. Then from C, you walked along this path, you reached B, and from B, you walk along this path and you come back to the starting point A. The total distance covered by you is pi r plus pi r plus pi r, which is, so it's like 1 pi r plus 1 pi r plus 1 pi r, which is 3 pi r. 3 pi r. 3 pi r. And what's the radius of the semicircle? What's the radius? 3 pi r. Radius.
The total
Radius. Yeah.
Ma'am, 7. 7.
What is 14 for the semicircle? What is 14 for the semicircle? What does 14 mean to the
Diameter,
semicircle?
ma'am.
Diameter. Diameter. Correct. For the semicircle, for this semicircle, AC is the diameter because semicircles are attached to the diameters. See, semicircles, here you can complete the circle. Semicircles are attached to the diameters. Quadrants are attached to the radii. The line segments attached to the quadrant are the radii. Semicircle is attached to the diameter. So the diameter of the semicircle is 14. Radius is equal to 14 by 2, 7. So the perimeter perimeter of the shape. Perimeter of the shape is equal to pi r plus pi r plus pi r, which is equal to 3 pi r, which is equal to 3 into 22 by 7 into R. Diameter is 14. Radius is equal to 14 by 2, 7. So into R, 7. Cancels 66 units. 66 units. Yeah, right on, children?
What we can just name it off.
Find perimeter. Find perimeter. And then take the figure. Find perimeter, take the figure and okay, the main heading is find perimeter. So you can see the second one under that. So the figure in the second one has 3 line segments and one other end is a semicircle. The boundary in figure 2, the boundary is made up of 3 line segments and one arc. That arc is a semicircle. You have to find the perimeter of the shape. So whenever you have a quadrant or a semicircle or a circle, you need the radius. So before you do anything, you have to first find the radius of the semicircle. That's not given. Other line segments, you know the lengths. Yeah, so first find the radius. Tell me the radius of the semicircle, children. What is the radius of the semicircle?
Mom, 3.5.
Yeah, who's that?
Lakshana.
Lakshana. Very good. Yeah, because when this is 7, you have to take the figure again in the answer. Okay, so in the answer, draw the figure again. Okay. 27. So this also is going to be 20 because the opposite sides will be equal. Twenty. This is 7. So this also has to be 7. This one has to be 7. Now this one is a semicircle, and the line segment attached to the semicircle is the diameter. So diameter of the semicircle is 7, which means the radius is 7/2 or 3.5 centimeters. We come again. This shape is made up of 3 line segments and 1 arc. That 1 arc is a semicircle. The 3 line segments, 7 centimeters, 20 centimeters, 20 centimeters. See, opposite sides are equal. This is 20 is not given. Opposite sides are equal, so 20. The arc is a semicircle. This one is a semicircle. So whenever you have any part of a circle, semicircle, quadrant, anything related to a circle, you need to find its radius. Now, this is the dotted lines represent the diameter of the semicircle or the circle. Okay, you can imagine the circle. We don't see the circle there. You can see the semicircle, but you can imagine the circle. See, like you can imagine the circle like this. This is a circle. You can imagine the circle. So this one is the diameter. Now opposite sides are equal. So this will be 7. Opposite sides are equal. So this one is 7. So diameter is equal to 7 centimeters. Because the line segment attached to the semicircle is the diameter. Diameter is 7 centimeters. So radius is equal to 7/2 or 3.5 centimeters. Now, how do you find the perimeter of the shape? 20 plus 7 plus 20 plus dash. Fill in the blanks. Perimeter is equal to 20 plus 7 plus 20 plus dash.
Pi r.
Pi r. 20 plus 7 plus 20 plus pi r, because that's a semicircle. See, we should not take into account the length of the diameter. That is inside the figure. You just need to go along the boundary. So 27, 20, and the length of the semicircle. This one alone. Only this one is on the boundary. This line segment you should not add. Don't get inside the figure. Just walk along the boundary. Whatever you encounter along the boundary, you need to consider only those lengths to find the perimeter. So 20 plus 7 plus 20 plus the semicircle pi r. And r is equal to 7/5, 7/2. So perimeter is equal to perimeter of the shape. Perimeter of the shape is equal to 20 plus 7 plus 20 plus pi r. Pi r. So this is 47 plus pi r. Pi is 22/7 into r, 7/2. Don't take 3.5. You can take, but take the fraction 7/2. So 7 cancels. 2 11 times. So 47 plus 11. See, this one should be simplified. Pi r. So this is 58 centimeters. Take down, children.
Mom, can you go to the next slide just for a moment?
Yeah.
Yes, ma'am. Thank you.
Got it.
Ma'am, can you go to the next slide or whatever that is, please, ma'am? I
Yeah,
haven't got.
Yeah.
You're done, ma'am.
Yeah. Yeah. This one also is semicircle. Yeah, find the perimeter.
Ma'am, the diameter is equal to 14.
Correct. Correct. Yeah, you can work it. Children, find the perimeter of the shape. Complete it yourself.
Mom, I got the answer.
So like the earlier one, the perimeter of the shape is equal to 18 plus 14 plus 18 plus this again is a semicircle. So pi r plus pi r. See here, walk along the boundary. Walk along the boundary. 18 plus 14 plus 18 plus this one, pi r. How do you go along the boundary of the shape? You walk like this, which is 18. Then you come like this, 14. You go like this, 18. And then you walk like this, which is pi r. 18 plus 14 plus 18 plus pi r. So that's semicircle. So 18, 18, 36, 50. 50 plus pi r. 50 plus 22 by 7 into 7. Pi is 22 by 7 into 7. So cancels. 50 plus 22 is 72 centimeters. Yeah, please check your answer. If there's any variation, please redo your answer. Rework. None, children? No, that was not clear. Yes or no? I'll wait. Okay. So that was about circle, semicircle, and quadrant. Next, triangle. So area is given by the formula half into base into height. Half into base into height, or simply half BH. Half into base into height, square units. If it's an equilateral triangle, if it's an perimeter is just the sum of the three sides. Perimeter of the triangle is the sum of the three sides. So supposing 7, 8, and 10, 7 plus 8 plus 10 is the perimeter of the triangle. Now, if it's an equilateral triangle, then the formula to find the area is equal to root 3 by 4 into a square or into side square. Root 3 by 4 into a square, square units. Triangle in general, half base into height. If it's an equilateral triangle, area is equal to root 3 by 4 into side square, square units. Side is also a, root 3 by 4, a square, square units. The perimeter, you know, the sum of the three sides. A plus A plus A, 3A. Perimeter is equal to the sum of the three sides. It's an equilateral triangle, so each side is equal to A units. So A plus A plus A, 3A units. A units. Correct? Equilateral triangle, all the three sides are equal. So if you call each side as A units, perimeter is equal to A plus A plus A, 3A units. Area is equal to root 3 by 4 A square units. Quadrilateral. Okay. So quadrilateral ABCD. Quadrilateral ABCD. Diagonal AC. I've used the letter D for that. D represents the diagonal AC, the length of the diagonal AC. BM and DN are perpendiculars from the opposite vertices B and D on the diagonal AC. See, now with respect to the diagonal AC, we have two triangles. With respect to the diagonal AC, we have two triangles. One is triangle ABC. The other is triangle ADC. ABC, ADC, with respect the two triangles with respect to the diagonal AC. Now, the vertex in this in triangle ABC, the vertex opposite to AC, is B. Opposite to AC in this triangle, the vertex is B. So from B, we have an altitude on AC. Similarly, in the other triangle ADC, D is the vertex opposite to AC. D is the vertex opposite to AC. From there, we have a perpendicular. You can see there's a perpendicular from D on AC. DN. BM and DN are perpendiculars. BM and DN are perpendiculars from the opposite vertices to the diagonal AC. Now, using all this, the formula to find the area of the quadrilateral is area is equal to half D into H1 plus H2 square units. Okay, let's understand how we get this formula. 1 second. Let me write that for you. So what is the area of triangle ABC? What is the area of triangle ABC? Using half base into height. Half into base AC into height BM. Area of triangle ABC is equal to half into base into height. Half into AC into BM. Now tell me, children, what is the area of triangle ADC? Half into half into base into height. The altitude falls on which side? AC. So half into AC into height dn. So half into d into h2. Now area of the quadrilateral. Area of quadrilateral ABCD is equal to area of triangle ABC, area of triangle ABC plus area of triangle ADC. Both the triangles put together, the areas of the two triangles put together is the area of the quadrilateral. So what's the formula for ABC? Half into D into H1. Half into D into H1 plus half into D into H2, the other triangle. So now what's common? Half D is common. Half into D is common. So in the bracket, you will get H1 plus H2. See here, half D. You have half D here, you have the same thing here, half D. So half D is common. Now what is left out in the first one? H1 plus this is left out in the second one, H1 plus H2. So that's how we get this formula. Half D into H1 plus H2 square units. Yeah, right on.
Mom, can you go to the next slide for a moment?
Yeah.
Yes, mom. Thank you.
Yep. Done the slide, children? So trapezium is a quadrilateral in which one pair of opposite sides are parallel and the other pair non-parallel. One pair of opposite sides parallel, the other pair non-parallel. Area is given by half into sum of the parallel sides into the distance between them or the distance between the parallel sides. So the trapezium looks like this, somewhat like this. It need not be exactly like this. So these two are the parallel sides. Trapezium PQRS. Trapezium PQRS, you can see PQ is marked parallel to SR. The arrows indicate parallel lines. Arrows indicate parallel lines. So when you have a figure like this, PQ is parallel to SR. PQ is parallel to SR. That means this quadrilateral is a trapezium because one pair of opposite sides are parallel. Now the distance between the parallel sides is always the perpendicular distance. The distance between the parallel sides is always the perpendicular distance. So area of the trapezium is equal to half into sum of the parallel sides, PQ plus SR, into the distance between them, the distance between the parallel sides, PN, square units. But supposing the trapezium is like this is called a right trapezium. This one is called a right trapezium. Right trapezium because these two sides are at right angles. In fact, these two sides also will be at right angles. So you can see this figure ABCD, in which AB is parallel to CD. We know that by the arrows indicated. AB is parallel to CD, so it's a trapezium. It's a right trapezium because you can see that two sides are at right angles to each other. AD and DC at right angles. Also DA and AB. Between these two sides, you can see the right angle here. Between these two sides, you can see the right angle here. So area of this right trapezium is equal to half into sum of the parallel sides, AB plus CD, into the distance between them. The perpendicular distance is AD itself. You don't need another special perpendicular, like in the case of PQRS. In the case of PQRS, you need to know the distance between them, the perpendicular distance between them, PN. The perpendicular distance between the parallel sides, PN. But here you don't have to know another, a line segment which is the perpendicular distance. AD itself, the side AD itself is the perpendicular distance between the parallel sides. Half into sum of the parallel sides, AB plus DC, into the distance between them is AD, because that itself is the perpendicular distance. Square units, right on? Okay, so for rhombus, we have two formulae. One is base into height, the other is half product of diagonals. So which one to use depends on the information given. If you're given the base and the height, base and altitude, base and the corresponding altitude, then you have to find the area using base into height. If you're given the details regarding the length of the diagonals, then you have to use a formula half into product of diagonals. Half into product of the diagonals. So half into MP into NQ, square units. So if information is given regarding the diagonals, the lengths of the diagonals, then you're going to find the area using the formula half into product of diagonals. That is half into diagonal 1 into diagonal 2. Okay, you can also say half D1, D2, children. Just make a note of that. You can also say half into D1 into D2. Length of the diagonal 1 into length of diagonal 2. Half D1, D2. Half into product of diagonals. Diagonal 1 into diagonal 2. It's also called half D1, D2 square units. So if base and height are given, base into height square units. Finish writing, children? No response. Okay, good. All right. Okay.
Done.
Yeah. Yeah. Find the area of this trapezium, children. It's a trapezium because you can see the arrows that indicate
They
opposite
all
sides are parallel. Half into sum of the parallel sides. Tell me the parallel sides.
24 centimeter. 34 centimeter.
Yeah. So 24 plus 34 into the distance between them. Is the distance between them 18, 20 or 26? Online children? Half into sum of the parallel sides. Into distance
20.
between them. 20, yeah?
Yes, ma'am.
Yeah, 20. You should take the perpendicular distance between the parallel sides. Not 18 or 26. The perpendicular distance between the parallel sides, 20. So you can cancel 2 ones are 2 10 times. 24 and 34 is 58 into 10, 580 centimeters square. So sometimes more information will be given to confuse children. You should be clear. 18 and 26 are just too much information about the trapezium, which is not required to find the area of the trapezium. It's just to confuse you, to make you think again if you should take 20 or 18 or 26. So 18 and 26 extra information, not required to find the area of the trapezium. Half into sum of the parallel sides, 24 plus 34, into the distance, 20. Okay, next one. Same heading, find the area. Yeah, find the area of the trapezium. And let's come back. Please try this. Yeah, final answer. Anyone wants to share your answer?
Ma'am, I'm Lakshmi. I got it as 210.
210. Okay, so what is it? How did you substitute half into?
Ma'am, 15 plus 20.
Okay, into?
Ma'am, into 12.
Very good. Into 12. Very good. So here we do not know the perpendicular distance between the parallel sides, because this is the perpendicular distance between the parallel sides, which is not given. And this cannot be regarded, 13 centimeters cannot be regarded as the perpendicular distance between the parallel sides. So you need to construct drop PE. So you need to say draw PE. See, not in the same. You need to draw the figure again, children. That's important. If you do it in the question figure, then you will not know what was given and what you have constructed. So you need to draw the figure again in the solution and say draw PE perpendicular to DC. Okay. $15. So draw BE perpendicular to DC. Now opposite sides are equal. So DE, this will be 15 centimeters. What will be the rest of it? How much is DEC?
5 centimeters.
5 centimeters. Because once after the construction BE, ABED is a rectangle. ABED is a rectangle. So opposite sides are equal. AB is 15 centimeters. So DE also will be 15. After the construction, ABED is a rectangle. Opposite sides are equal. So DE is 15. So EC will be 20 minus 15, 5. 20 minus 15, 5. Because the whole thing is 20. This full thing DC. This full thing DC is 20. DC is 20. DE is equal to 15 because the opposite sides are equal. So EC, the rest of it will be 20 minus 15, 5 centimeters. Now, in right triangle BEC, in right triangle BEC by Pythagoras theorem. Now, the three sides of the triangle are BE, EC. Write the hypotenuse separately, BC. The three sides of the triangle BEC are BE, EC, and BC. BC is the hypotenuse. So I've written it separately in the RHS. Now square all the three sides. So the square on the hypotenuse is equal to the sum of the squares of the other two sides. So BE square we don't know. We have to find plus EC square, 5 square is equal to BC square, 13 square. So BE square plus 25 is equal to 169. B square is equal to 169 minus 25. BE square is equal to 144. BE is equal to square root of 144. BE is equal to 12 centimeters. The perpendicular distance between the parallel sides is 12 centimeters. Now the area of the trapezium. Area of trapezium ABCD. ABCD is equal to half into sum of the parallel sides AB plus DC into distance between them BE. Half into sum of the parallel sides AB plus DC, not DE, DC. The complete side AB plus DC into distance between them BE. So on substituting half into 15 plus 20 into 12. So you can cancel 2 ones are 2 6 are 15 plus 20 is 35. 35 into 6 is 210 centimeters square. Lakshana, perfect. 210 centimeters square.
Ma'am, so over here, half into sum of parallel sides into distance between them. Distance between them is basically the altitude here, right?
Yeah, the altitude from the vertex B to the opposite side DC. The term altitude is used only in a triangle. Here it's a perpendicular. The perpendicular from the vertex B to the opposite side DC, the perpendicular.
Okay.
Yeah. So distance is the perpendicular distance. So you should not take BC. BC is not the distance between the parallel sides. BE. When we say distance, it's a perpendicular distance. So I said 2 and 12, you can simplify 6. Then 35 into 6, 15 plus 20 is 35. 35 into 6, 210 centimeters square. So next class, positively, we are discussing the answers to the case study based questions and assertion reason statements. Please keep it ready, all of you. And in case I continue with the mensuration, kindly remind me that we have to discuss the answers. Please remind me. So those who have not completed, get a little more time. So if you complete it, it'll be more interesting for you when we discuss the answers. All right, children, I hope the session was useful. Any doubts, you can ask me in the next class. Now it's time. Go through all this. And if you feel some part of today's lecture was not clear to you, you can ask me. I'll be happy to repeat it in the next class. All right, children, that's it for today's session. Thank you so much. Online students can leave the call. Good night.
Thank you, ma'am.
Thank you.